Hello, 7th graders. We're going to talk about Chapter 6, Section 5, Similarity and Measurement. So we're going to go along and go off of more with our ratios and comparing two similar figures. And now we're going to try and find out what our ratio is, set it up as a proportion, and solve for our missing factors. So let's do some examples. That's the best way to do this. So we start off. Given triangle STU is similar to triangle DEF, we need to find DF. So in the black it gives us our original measurements. So STU, so TU is 45 millimeters, SV is 35 millimeters, and EF is 36 millimeters, and DF is what we're trying to find. So my little trick that I did earlier was I like to put the corresponding parts to both angles so I can see what I have and what I don't have. So again, what you set up a ratio, so you use the ratio of the lengths of corresponding sides to write a proportion. In this case, we're going to use the unknown length of DF. So if we look here, we can see that EF up at top, and our corresponding part to EF is TV, and then equals, and we want to have our unknown in there, DF, and our corresponding part to DF is SV. So that's how we would set it up initially. Now you plug in your numbers. So you know EF is 36 millimeters, TV is 45 millimeters, equals, well, we don't know what DF is, that's our unknown, X, and SV is 35. And from here, we have a proportion, and we solve our proportion. So we cross multiply. 45 times x equals 36 times 35. So 45x equals 1,260. Divide by 45, and you find out that x equals 28 millimeters. And because they are similar, we know that that ratio stays the same for all corresponding parts. Let's do another one, just to make sure. So if we have a quadrilateral, in this case parallelograms, but we're given that JKLMN, so JKLM, is similar to PQRS. Find PQ. So again, I like to set it up so I know what all my parts, my corresponding parts are. And so I say, okay, so we have J is corresponding with P, Q is corresponding with K, R is corresponding with L, and S is corresponding with M. Now I need to set up a proportion using my ratios. And again, you need to make sure that when you set them up, you have numbers to fill in and you only have one unknown. So that's really important. So here, I know I have to use JK and JM somehow and do the corresponding parts. So it also doesn't matter which one you put on your numerator and which one on your denominator, as long as you're consistent. So here I use the large quadrilateral on top, and you can see I also use the large quadrilateral as the unknown on this part, but I could easily flip-flop it. So let's do this one. So we have SP, and its corresponding side is MJ, equals X, and its corresponding is JK. And you can see here those match up with my numbers. So then I fill in my numbers. 35 inches over 21 inches equals X over 36 inches. And then I will solve for X, multiply 21 times X equals 35 times 36. And you get 21X equals 1,260 divided by 21, and you find out that X equals 60 inches. So now we're going to step it up a minute, and we're going to use more real-life examples. So with this, we can use similar figures to find lengths that are difficult to measure directly. So what we're going to do is we're going to use an example of cactus, or cacti is the plural, and shadows. And you can do this with buildings, you can do this with all sorts of real-life figures in real life. So our problem is a cactus is 5 feet tall, and it casts a shadow that is 1.5 feet long. How tall is a nearby cactus that casts a shadow that is 8 feet long? So I have to draw a picture. It doesn't matter what your picture looks like. It's not art class, as you can tell. So I drew a picture of my first, what I know. Well, I know I have a cactus that's standing up, and I know it casts a shadow. And then I say, okay, well, my height of my cactus is 5 feet, and its shadow is 1.5 feet. Okay, and I'm going to call this cactus 1. My nearby cactus, I'm going to call cactus 2. Well, I don't know how high it is, so that's my unknown, my X, but I do know it casts an 8-foot shadow. And since it's a nearby cactus, we're assuming that we can get a good estimate of how long it is with the shadow lengths. So I set up a ratio first, cactus 1 height over cactus 2 height, and then that would equal my shadow 1 over shadow 2 and make it into a proportion. Now again, I could do cactus 2 height over cactus 1 height, but then I would have to do shadow 2 over shadow 1. You just need to be consistent. So now I fill in my numbers. So my cactus 1 height is 5, cactus 2 height is unknown X. My cactus 1 shadow is 1.5 feet, and my shadow for cactus 2 is 8 feet. And then I solve again for X. I cross multiply, so 1.5 times X equals 5 times 8. 1.5x equals 40. I divide it out, and I changed it into a fraction because I am working with feet and measurement. So I find it's 26 2/3 feet. Well, 2/3 of a foot is 8 inches. So I found out that my cactus is about 26 feet 8 inches long. So there's another way, and this is our last example here, is if you have similar triangles within each other, basically. So here we have given. So we have GHJ is similar to triangle GKL. And I need to find GH. So what we need to do here is we figure out, again, proportions and ratios. So I set up. I say, okay, well, I know LK and I know JH. So I can put those as a proportion. My big triangle LK over my small triangle JH. And I need to find out what my base is, or the bottom part. So I need to find out what HG is, which is going to be X. But the base encompasses HG and KH. All right, so KG is actually KH plus HG. So if I put it into a thing here, so I can see right here, my segment KG equals KH plus HG, and that's what I wrote here. And that's my proportion. So then I go through and I plug in my numbers. 21 centimeters over 7 centimeters equals, well, 20 centimeters plus X divided by X. And that's my proportion. Then I will cross multiply. You still do the same thing. So you have 21 times X equals 7 times your whole quantity, 20 plus X. So don't forget, when you have your 7 next to a quantity, you need to distribute. So now I get 21x equals 140 plus 7x. I need to solve for x, so I need to get all of my x's on one side of my equal side and all my numbers, whole numbers, on the other side. So in this case, I need to get 7x from the right side onto the left side. So I add the opposite. So I have subtract 7, 21x minus 7x is 14x equals, bring down 140, divide by 14, and I find out that x equals 10 centimeters. So tomorrow in class we will be doing more of these, and I will be answering any questions. Have an excellent night.